We're going to do the problems from section 3.2. Spend a bit less time on these. We're just going to write the answers down. So really, theoretically, for the problems, I'd like you to try these yourself, and then you'll just see if you get the answer right. So, and if you need further help on these, you have office hours, or you can send me a message or something. So find all values x equals a where the function is discontinuous. For each discontinuity, find f of a if it exists. It's basically the same as the example we did. So looking at that graph from part A, where are the discontinuities? There's one at x equals -2, so there's a discontinuity. This is part A. There's a discontinuity at x equals -2. And then there's another one at x equals 3. The limit as we approach a from the left and from the right, the limit as we approach -2 from the left, where this function f of x, is in fact actually the same as the limit as if we approach it from the right. And then that is itself just going to be the limit itself. So the limit from the left and the right are the same, and therefore the limit itself is the same, and they're all -1. You can see that the graph sort of goes down to that point, and that point has a y value of -1. For the other one, the limit as we approach 3 from the left, that's the same as if we approach 3 from the right, so it's kind of the same idea. And then that's going to be the same as the limit itself, without the plus or the minus on it. So they're all the same, and in this case they're all also -1. You see that's where the hole in the graph is. If we approach from the left and from the right, they kind of approach that hole. That hole has a value of -1. Oh, and it looks like I've skipped part A. We also needed to find the f of these two values. So f of -2, you notice that there's a little filled in circle there at 1. So f of -2 is 1, and that's the same thing for f of 3. That's also 1. Okay, for part B, you've got discontinuities at those asymptotes, and you also have another one right where that hole is in the middle. So the discontinuities are at each asymptote and then where that little hole is in the graph. So that's at -5 and 0 and what is that, 5? Oh no, actually I'm sorry, that is not a discontinuity. The graph continues down there. I don't even know why they put that vertical line there. So just those two discontinuities. Since there is an asymptote there, that means that f of -5 is undefined. And there's the other, at 0, there's a hole in the graph, so f of 0 is also undefined. The limit for, as we approach -5, that's not going to exist, because there's an asymptote there. And on one side it goes up, the other side it goes down. So this doesn't exist. As we approach 0, the graph sort of comes up towards 0 from one side, and it comes down towards 0 on the other side. So that one, the limit will exist. So the limit as x approaches 0 for this function is actually just going to be 0. And it doesn't look like I'm going to, well, let's see. For number 2, yeah, I don't think I'm going to have room. I'm going to make another video for that one, so that'll be part 2 of this.